explain the idea behind it?
First, we are generating signals. This cable, right? Generating signals. Like you can see on the oscilloscope. So, can you the oscilloscope? So I'm pressing a key on the oscilloscope. Can you see it? Can you see those? So those are the different signals. So each letter has a different width. Okay, so depending on the baud rates, I'm going to narrow the baud rate so that the number of symbols per second be large enough so that it can, my frequency can respond to it. I'm talking about 1 something here. So let me show you here. Here. Okay, put it on there. So I'm around about 1.3 kilohertz. Okay, that's what you see on the oscilloscope. The first one on the oscilloscope. Okay, so I have to drop my baud rate to about 600. Okay, so that it can modulate. So the idea here is when I have all these signals coming in, the signals here coming in, my phase lock would, generate these frequencies, and these frequencies will be coupled onto a power line. And then this is the first. Put it here. This is the first. This is the transmitting phase lock loop, which generates the baseband. Okay, and then this is the receiving phase lock loop, which is listening, as you can see, through this cable onto the line. So we are assuming this is a power line. Now, whatever comes on this point is supposed to be reflected onto this point through frequency, and then the total response will now be brought out through this point as voltage and voltage changes, which the microcontroller is going to interpret and carry out the requisite controls. So far, this is the crust of the whole project. This is the main project. So these first parts are the frequency side. Then we'll cut off this part and then make it, add the coupler so that it can be introduced on the power line. Once introduced on the power line, we have 50 Hz on the power line plus some noise. And then we have our signal. So we're assuming it's a noiseless channel. Now when the frequency, the phase lock loop is locked onto this 1.3 kilohertz. So when it sees anything outside that frequency, then it shuts off. But when it sees anything within that frequency, then it gives the corresponding changes. So, and then we can interpret it at the other end. Okay, so thank you. Okay.